In this circuit, we're asked to compute what V1 and V2 are, and I'll use node voltage or nodal analysis to do this. And in this time, we were given what the reference node is, so we're going to have to deal with it that way. And I think it's a good choice of reference anyway. So as identifying all the voltages, we're going to see that if this is the reference point, that's a 0 point. Well, I don't need to compute it or write any equations in here because this is 5 volts above the 0, which is good. Well, that gives me V1, we need to write an equation, and V2, we need to write an equation. But we also should recognize in here that we have a voltage source between two essential nodes. So that means I should treat this particular equation in here as a supernode, or this particular two nodes as a supernode. We still treat V1 and V2 separately, but we write one equation in here. And the second equation that relates V1 and V2, which I know this is a voltage source, so I know that the V2 is higher than V1 by this amount, but this amount is relevant to some sort of a current because it's a current control voltage source. So we're going to have to write an equation to get that. Anyway, so let me get started by writing the equation. So let me just see how many equations do I need in total. Well, in terms of nodal analysis, I only have this one supernode. I don't need anything else. So I just need to write a KCL equation for a current leaving in here, in here, in here, and in here. So those are 4 different currents. So let me write the equation. Okay, so we're going to write KVL or KCL at the supernode. Okay, so the KCL at the supernode, so let me just do that in here. That will be V1 minus the 5 volts divided by the 4 kilo ohms. Okay, so we're having 4 kilo ohms, so this is V minus 5, good, all right. And then the next one in here, which is V1 divided by 2.5, and that's through the R3. And then we ignore the current going through this. We move to the second node in here, and that will be V2 minus 5 divided by 2. That will be V2 minus 5 divided by 2. Let me just clean up this here a little bit. So that will be V2 minus 5 volt divided by 2. Good. And then here, which is the last current, that will be a plus V2 divided by 3 kilo ohms, and that should equal 0. And we need to clean this equation a little bit. And that would look something like that. This will be our first equation that relates V1 and V2. So we're going to call it, this is equation 1. And we go back in here. Where do we get the second equation? Well, we said we get the second equation just from the constraint equation itself, or well, using the constraint equation. So let's see this one here. This tells me that V2 is higher than V1 by 2000 A. Okay, so let me just write this one in here. So that tells me that V2 minus V1 is simply the value of the voltage source, which is 2000 IA. All right, but what about IA? Where is it? Well, IA is here, and we can compute it the same way we computed node voltages. We could say it's the voltage in here minus the voltage in here divided by 2 kilo ohm. Okay, so let me just write it in here. So then we'll have IA is simply the 5 volts minus, I believe, V2 divided by the value of that resistor, which is 2 kilo ohms. Now, something that we need to pay attention to, that this here, usually whenever you see these voltages or these dependent sources, they're typically in volts, okay? And they assume that this is an amp because I didn't give you the units of the 2000. Okay, so if I didn't give you the unit of the 2000, you should assume that the default should be this is in amps, volts, and so forth. It won't be in kilos or millis. Okay, so in here, what we have is 5 volts minus V2 is in volts, and this is in 2. Because this is in kilo ohm, that is assumed to be in milliamps. So I need to do some conversion. So if this is an amp and this is a milliamp, I need to do some conversion. So this one in here, since it is in milliamp, what I will do is I'll convert it to amps. Okay, and then we'll go from there. So that will be times 10 to the basically -3, since it is in milliamp. Okay, all right, so we do that, and that will be the IA. So what we need to do is we need now to combine these, and we'll combine them. We'll see that V2 minus V1 equal 2000, and that will be 5 minus V2 divided by 2. Okay, and frankly speaking, this is divided by, like, I could have just, instead of doing that, I could have just said, you know what, instead of 5k and 5 to the -3, I could have just basically said this should be 2000. It's the same effect. So this will be 2000. The reason why I did that is because I technically can now eliminate this with that. So that will give me that V2 minus V1 equals 5 minus V2. And we clean up this equation a little bit, and we'll end up that V1 or negative V1 plus, I believe if I move the V2 plus 2V2 equals 5, and that will be the second equation that we need. So I have two equations, two unknowns. All I have to do is just solve them, and I should be able to get the answer that I'm looking for. So let me just do that. So the answers I got are V1 should be, let me just write it in a different color. Okay, V1 should be 25 divided by 16, or simply 1.5625 volts. Okay, and that also tells me that V2 should be 105 divided by 32, or simply 3.28125 volts. Okay, so now I have my V1s and V2.